the bad news is because we got 3 variables, there's a lot more information to consider here, right? Instead of 2 variables, I got 3 variables. Instead of 2 equations, I got 3 equations. So I have to manage more stuff. Okay? The good news is the strategies that I use for 2 variables and 2 equations are the same strategies that I use for 3 variables and 3 equations. Same strategies, okay? Earbuds, please. Earbuds. Okay? So we're going to go over those strategies together. And then I'm going to give you an additional strategy after that so that you don't have to do quite so much writing. Okay? So let's start with what were the things that we did in solving a system of 2 equations and 2 variables. There was one strategy was called, started with an S, substitution, right. And the other strategy,
elimination.
Say it with confidence though. Elimination. There you go. Those were the 2 strategies that we had. Okay? Now, we're going to use those same strategies, but we're going to use them together. The first strategy we're going to use is elimination. Okay? Now, this whole process is called, no, I want black. Gaussian and Gaussian row elimination and back substitution. Say that 3 times fast. That's 1 time and it wasn't very fast. And there's only 1 person saying it too. Anyhow, okay. All right, so judging by the name, what are we doing first? We're doing elimination first. Okay, good. Now, this one's pretty easy. This one is pretty easy because I can add 2 equations to each other to get rid of 1 variable. Top 2. I can add those 2 together, and what's that going to get rid of, Henry? As x's, okay? So let's add. I'm going to label these. I'm going to label these row 1, row 2, and row 3. Okay? Now, I'm going to keep row 1. Row 1. Oops. Row 1. So, row 1 is x minus 2y plus 3z equals 9. But I'm going to make my new row 2 is going to be the sum of row 1 and row 2. So when I add row 1 and row 2 together, that's going to be my new row 2. So x plus negative x is 0x. And I'm going to write that down from now just to keep my accounting straight. 0x. And then I got negative 2y plus 3y gets me 1y. So plus y. And then 3z plus z gets me plus 4z. And then 9 plus negative 2 gets me equals 7. Okay. So, and then I'm going to keep my row 3. Row 3 is 2x minus 5y plus 5z equals 17. Don't, no spoilers. No spoilers. Okay, now I'm going to do the same thing again, but I'm going to do it to get rid of this guy. So how would I get rid of that guy? What's that? Subtract 2x. How am I going to get 2x? How am I going to get 2x?
Multiply by -2.
So multiply what by -2? Row 1? Yeah. So here's what I'm going to do. My row 1's going to stay the same. So row 1 is going to stay x minus 2y plus 3z equals 9. Row 2 is going to stay the same. And that is y plus 4z equals 7. But row 3 is, I'm going to take 2 times row 1, actually -2 times row 1, and add it to row 3. Okay? So what's -2 times row 1? That would be -2x plus 4y minus 6z equals -2, -18, right? So, and I'm going to add that to this. So -2x plus 2x gets me 0x. I need to be in blue now. 4y plus -5y gets me -y. So minus y. And then -6z plus 5z, -z, and then -18 plus 17 gets me -1. Okay, so now I've gotten rid of all my x's except for right here, yes? So now I am done with my x's. I'm going to just erase this guy because that's Department of Redundancy Department stuff, right? So now that I've gotten rid of all my x's except for here, I want to start getting rid of y's. But first, no, we're going to get rid of y's. Yeah, so first of all, let's, no, I want that in red because I'm OCD like that. So row 1, I'm keeping x minus 2y plus 3z equals 9. Okay, I'm keeping row 2. Row 2 is y plus 4z equals 7. But my row 3 is going to be what? It's going to be row 2 plus row 3. That's going to be my new row 3. So row 3, and why do I want to add row 2 and row 3? Get rid of my y's, right? So y plus -y gets me 0 y's. And then 4z plus -z gets me plus 3z. And then 9 plus -1 gets me 8. So now I got 3z equals 8. Oh, yeah, so it's 6. Good catch. Good catch. 6. Right? So, Jet illustrated the need for good accounting here, right? Good accounting. Good catch, Jet. So now, I got 3 new equations. And I'm going to get rid of this because, again, Department of Redundancy Department. What does z equal? 2. Z equals 2. So I'm going to change that as well. This is just going to be z equals 2. Z equals 2. Now, what can I do? So now,
Plug in 2 for R2.
I am done with row elimination. what was my strategy? My strategy was to make these zeros and this 0. Now I know what z is. Can I plug z back into here? And then I get what? I can solve for my y. So now I'm in back substitution. So I do, again, row 2. I'm just going to write row 2 right now. And it's y plus 4 times 2, because z equals 2, equals 7. So y plus 8 equals 7. So y equals what? -1. Subtract 8 from both sides, right? So now y equals -1.
Huh.
Now I know what my y is. I know what my z is. Now what can I do?
Plug them into R1.
Plug them into R1, right? So let's do that over here. R1. So x minus 2 times -1, that's my y, right? The y goes there, plus 3 times 2 equals 9. So then I simplify. Boom, boom. So x plus 2 plus 6 equals 9. Did I do that right? So x plus 8 equals 9, x equals 1. So now I figured out all 3 of my variables, right? I found the solution to this system of equations. What is a solution again?
They cross all 3 of them.
That's the consequence. What is the definition of a solution? A solution is values of a variable that make my equations true. Do we remember that all the way back from Algebra 1 at the beginning? When we said solve for x, we're really finding a value for x that makes that equation true. And that's what we're doing here. Okay? Now, I'm going to throw in a little bit of 7.4. This is a lot of writing, right? I can do the same thing. But I don't need to put the x, y, and z in there, do I? Instead, here's what I do. 1, 2, 3, 9.
-2. Oh.
0, 1, 4, 7, 2, -5, 5, and 17. What in the wide world of sports is that? Hush. Don't say a word.
Knew it was coming.
Don't say a word. What is that? That is a matrix. Thank you, Dawson. Who saw this on the ACT? You had a 2 by 2 matrix on the ACT.
That's the one I answered C for.
You had, and it gave you A, B, C, and D. And it said the determinant, it gave you capital A equals that. And it said the determinant of A equals AD minus BC. And then it gave you numbers for this matrix, right? It said like 1, 2, 3, 4 or something like that. We were supposed to find the determinant. And what do you have to do there?
Plug and chug.
Plug and chug. We're going to find out what the determinant means. At least that's my hope. My hope is we get that far. But right now, what is a matrix? It is a representation of a system of linear equations. That's all it is. So this one here stands for what? It stands for the coefficient in front of my x variable, right? And the -2 is the coefficient in front of my y variable. And the 3 is the coefficient in front of my z variable. All right? So this is what I want you to get out of this lesson today is A, how to do row elimination and back substitution, and then understand this concept, okay? One last thing about this notation is we always put square brackets around our matrix. Okay? And what do you think this line right here represents? That's the equal sign right here, right? Good. Okay. We clear on that?
Yep.
So tomorrow, who thought it was unfair for me to have, you don't even know the question yet. Who thought it was unfair for me to make this assignment due today on the same day that I made the final due?
There you go, Ryan.
All right. Who didn't do this assignment? All right.
Didn't know what to do today.
Do tomorrow.
Sick.
Those of you that did it today, go ahead and turn it in. You'll get a couple extra points for the cause.
Yeah, wait,
Oh,
no.
question. Final due end of the class or end of the day? When do you want to turn it
The
in?
final was due last night.
What?
Oh no, you're right. It's due tonight. I'm sorry. Did I scare y'all?
Yeah, for a
Did
little
I
bit.
scare
yeah.
y'all?
So
Who
tonight,
just soiled their drawers?
Dawson, your dog
All right.
can't
All right.
spoil your drawers. So midnight tonight.
Midnight tonight. So 11:59, Riley,
Yes.
and 58 seconds.
I've actually done something at 11:57 before.
What happens when your Wi-Fi goes out?
Mine usually goes.
Data, what kind?
Emphasis on the term usually, right?
Yes.